Hi there and welcome to another grade 10 session, Learn Extra. Today we are going to learn extra about statistics. Statistics is a very interesting branch of mathematics and it's used a lot in daily life. So it doesn't matter really what sort of career that you will end up studying for. Chances are sooner or later you will come into contact with statistics, and it's a good idea that you know what you're doing. Now, statistics shouldn't be new to you, grade 10s. You've already learned a little bit about statistics in grade 9. So what we're going to do today is we're going to go over the concepts that are necessary from grade 9, and we are also going to extend and learn about some new things. So the first thing that I'm going to talk to you guys about is collecting, organizing, and representing data. Now, guys, in statistics, basically what we do is we analyze information. Before we can analyze the information, obviously, we have to collect the information. So, how do we collect the information? There are plenty of different methods that we can use. We can use a questionnaire, we can use a survey. Think of the census that was done, I think it was last year. We can perhaps stand at shopping centers, ask people questions, or we can sit down somewhere, observe certain behaviors, have a look at the color car that people prefer, and so on. So there's lots of different ways to collect our data. Now, what we are most concerned about in our statistics course is organizing our data. We're going to have a look at organizing our data either into groups, that would be group data, and ungrouped data as well. Furthermore, we're going to talk about how do we represent the data. If your boss sends you out to do a survey, you can't just come back to him and say, well, here is a whole pack of questionnaires that I collected at a shopping center. That's just not going to work. You will have to analyze the data and you will have to represent it in a way that makes it visually pleasing, that makes it visually self-explanatory. And for that purpose, we are going to be having a look at pie charts, bar graphs, histograms, as well as line graphs. Right, so let's first talk about our measures of central tendency. Measures of central tendency, this is very important terminology. Our measures of central tendency are our mean, our median, and our mode. So measures of central tendency means we are looking at common things like a center that it tends to. So from last year, you guys should know that mean is represented by an X with a bar on top, and a mean, quite simply, is an average. Now, how do we calculate the average? We add together, or sum, all of our different pieces of data, and we divide by n, and n is our sample size. So if you are calculating the class average for a class of 30 people, you will be adding those 30 marks together and you will divide by n, which is of course then 30. Next up is our median. Now our median is also called Q2, and the median is quite simply the middle value if the data has been arranged from smallest to biggest. Now, at this point, boys and girls, I am talking about ungrouped data. Mean, median, mode is for ungrouped data. I can also, for group data, calculate an approximate mean, a median class, and a modal class. But with ungrouped data, I'm looking at each individual piece of data. I haven't placed them in different categories. So median, our middle value, if the data is arranged from smallest to biggest. Now, mode is our data that occurs, our data piece that occurs most often. So none of this is new, boys and girls. Mean, median, and mode, all of those things we dealt with in grade 9. So let's have a look quickly at an example. So the question says a group of 13 learners did community service at a local animal shelter. The data below shows the number of hours each learner spent at the shelter during the April holiday. And the first question is to calculate the mean. Right, so I'm now going to calculate the mean number of hours that these learners spent at the animal shelter. So in my mode, in my calculator, I'm going to go to stats, and then I'm going to press number 1. You can obviously just do this using an ordinary calculator, adding all the values together and dividing by 13, but this is quite an easy method not to get confused because you can see what you have entered. So I'm going to say 14 equals 16, that's not 16, 16 equals another 16 and another 16, then 17, 20, 21, 24, that's a long time at the animal shelter, 30, 32, 34, 36, and 40. On your calculator, you can then go AC, Shift 1, and you will be given a couple of options. Now, the one that we're looking for is number 4. All calculators have different ones, so you're going to go to mode, you're going to say stat, then you're going to pick 1, then you're going to enter your data, putting an equals after each data piece, and then you're going to go AC Shift 1, and you're going to press number 4 on your calculator, and this is the screen that is given to you. I want to calculate the mean, so I'm going to be pressing number 2 and equals, and the mean number of hours spent at the animal shelter is 24,3. Now I'm going to write that down, 24,3. Obviously, what you will do is you will have a look at the rounding instruction that is given to you on the front of the paper. It might say round to the nearest hour or something like that. You will just follow that instruction. The next question asks us to determine the mode. So the mode is the number that occurs most frequently, and I see that the number that occurs most frequently is 16. Right, so that was our first question. All we had to do was calculate the mean and the mode. Moving on to question 2. The mass of grade 10 learners are measured in kilograms. Now, I wonder how they got 10 grade 10 learners to stand on the scale, but never mind. And we have a look at the masses starting from 48 and ending at 70. It looks like the data has been arranged from smallest to biggest, so that's really quite nice. The question to us is calculate the mean and the median for this data set. Right, out with the calculator again. Mode, stat, mode, stat, and I press 1, and over there I've now got a brand new column, and I'm going to enter my data. 48 equals 55 equals 58 equals 60 equals 61 equals, then I've got two 64s, and let me just move my calculator to see what comes after the two 64s. It is a 65, 68, and 70. And AC, Shift 1, I pick number 4, then I pick number 2, and the mean mass is 61,3 kilograms. So I'm going to do it like this. I'm going to say mean is 61,3. And boys and girls, remember your units. We are dealing in kilograms. We know this, so you have to write that down. Right. The next question asks us to determine the median. So very important that I just quickly count how many. Oh, that was 10 learners. So that was told to us. So what I'm going to do is I'm going to go 1, 2, 3, 4, 5. And if we have an even number of pieces of data, our median will always fall between two values, very important. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, slap bang in the middle. Now remember, if those two data pieces are not the same, I have to add them together and divide by 2. So going out of this stat mode, or not that that's difficult, mind you, halfway between 61 and 64 will be 60, that's 125 divided by 2, so that's 62,5. And that is my median. There's no special sign to indicate that I'm calculating the median, so just write that down. Right. There's another question on the same data set. So they say the mass of 10 grade 10 learners are measured in kilograms to obtain the following data set. Been there, done that. An 11th learner who has a mass of 89 kilograms is added to the sample. What effect does this value have on the mean and on the median? Okay. Now, the most important thing that you guys have to realize is that this 89 kilograms is a lot more than all of the other masses. It's, if I write it in here, you can see it's a full 19 kilograms heavier than the 70 kilograms. Now, guys, a data piece such as this, which is very far outside of the range of the data, is called an outlier. Right. Now, they're asking us what effect the value will have on the mean and the median. You don't have to recalculate. Obviously, this is going to have an effect on the mean. It is going to increase the mean quite significantly because there's 19 kilograms extra, bigger than the last one that I'm adding, and I'm only dividing by 1 more. So it is definitely going to increase the mean. Well, what about the median? That it won't have such a big effect on. Typically, an outlier affects mostly the mean and not so much the median. I now have 11 data pieces, so I'm going to count 1, 2, 3, 4, 5. 64 will now be my middlemost number, and I think you guys will agree that that's not such a big difference from 62,5. So big effect on the mean, not so big an effect on the median. Right. We are now going to have a look at the different methods that we can use to represent the data. So we've collected our data, we have done certain calculations on our data, and now we want to display it, like perhaps in a presentation or something like that. Now, when we are representing grouped data, the most common ways of representing grouped data is by using a histogram or a broken line graph, a frequency polygon even. Just a quick note, boys and girls, let's quickly talk about the difference between a histogram and a bar graph. That is often a point of contention. Now, a histogram also has bars, so we'll have our classes of whatever, but the bars of a histogram touch each other. Typically, a histogram is used to measure something of a continuous nature, so, or to represent something of a continuous nature, like for instance, the mass of the learners or the length of a leaf or something like that. Whereas a bar graph looks a lot the same as a histogram, but it has individual bars that don't touch, and the type of data represented by a bar graph is usually discrete data. Like, for instance, are you a boy or are you a girl? Something like that. Or how many white cars? You can only have 5 or 10 or 100 white cars. You can't have 5.5 white cars. However, if you're representing something like the mass of students, obviously you can weigh 55 kilograms or 55.5 kilograms. So very important that you guys understand the difference between a histogram and a bar graph. Right. We are now going to start working with grouped data. Now remember, up to now, all of our data has been ungrouped. But typically, if we are looking at the height of people or the masses of people, it makes a lot more sense to put our pieces of data in different classes. The reason for that is if you had to weigh 20 learners in your class, the chances that two people have exactly the same mass is very, very slim. So it therefore makes more sense to group people into groups. So let's have a look at some group data. The data below gives the height in meters of 30 professional soccer players. The heights are arranged from shortest to tallest. Right. What I'm now going to do is I'm going to group this data into these different classes. 155 to 160 centimeters, 160 to 165, and so on. Now, boys and girls, usually the groups that you have to use will be given to you. However, if you are asked to group the data yourself, it's very important that you remember that your class intervals, your groups, all have to be the same size. I can't have 150 to 160 as my first class and then 160 to 165 as my second class. Now, what I'm going to do is I'm going to fill in my table. I'm going to go through every piece of data, and I'm literally going to do a tally table. So group the data into 5 centimeter intervals. Right. 158 falls in this class. 159 in this class. 162 is in the next class. 164 is in the next class also. 165 is still in this class. 168 in the next class, and so on. 170. So there's 5 there altogether, and another one is 6. 171 is over here. 172 and 173. 274s. And another one, 175. Right, so then we get to the next class. 176, there's 1, 2, 3, 4, 5, 6, 7 people in here. I'm actually just going to stop the tallies and just do a 7. Let's check that again. 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5. I'm just going to quickly go through my data again and just make sure I haven't made a mistake. Lower than 160, there were only the 2, so that's correct. I'm going to write my frequency as 2. Between 160 and 165, 1, 2, 3. That's correct. Let's write our 3. 165 to 170, 1, 2, 3, 4, 5, 6. Correct. And then 1, 2, 3, 4, 5, 6, 7. I actually put 8, so I need to correct that. 1, 2, 3, 4, 5, 6, 7. So this is 7. Right, so I've done that. I've filled out my frequency table. Right, now we are going to use our group data to calculate the estimate mean. Now remember guys, the moment we have grouped our data, our mean is no longer the mean, it is an estimate mean, because the moment we put our data into groups, we lose the individual identity of the pieces of data. So I have done my frequency table. I've filled in the numbers of soccer players that fall into each class. So I've got that on the right hand side here, so that's fine. The next thing that I now need to do is I need to calculate my class midpoint. Now I've put in an extra column for that. You calculate the class midpoint by adding the the 155 and the 160 together and dividing by 2. So my class midpoint is 157,5 for the first class, 167,5 for the second class. Sorry, no it isn't. Just goes to show you, let's do it properly. 160 plus 165, or what, that is going to give me 162,5. And the next one will be 167,5, and then 172,5, 177,5, and my final class will be 182,5. So important, you first need to group your data. Then you need to draw up a frequency table. Then you need to calculate the class midpoints. Now what I'm going to do is I'm going to multiply the frequency with the class midpoint and add it to the next frequency multiplied by the class midpoint. Add it to the next frequency multiplied by the class midpoint, and then in the end I'm going to divide by 30. Now, it is much easier to do this on your calculator, so let's have a look. You have to get your calculator into the form where you've got two columns. So one is for the data and the other one is for the frequency. So what I'm going to do is I'm going to enter this now. I'm going to say 157,5 equals. I'll do all the midpoints first and then I'll do the frequencies. That's easier. 162,5, 167,5, 172,5, 177,5. Be very careful while you're entering. It's so easy to make a mistake. And 182,5. Right. Then I scroll over to my frequency side. I'm just scrolling right to the top. Well, I try to. There we go. And I'm now going to enter the frequency. So I'm going to say 2 equals, 3 equals, 6 equals, 7 equals, 7 equals. Oh my goodness, I made a mistake and I didn't even see that. So I'm going to enter 2 and press equals, 3 and press equals, 6, press equals. Remember to press the equals, otherwise your calculator is going to give you a syntax error like I just had. And 5 equals. Right, so I've got my class midpoints in the one column, I've got my frequencies in the other column, AC shift 1, and I'm going to select number 4, and I'm going to calculate the mean, which is X bar, and my approximate mean, remember now boys and girls, it's an approximation because you're not using the discrete individual pieces of data, you are using a midpoint. So my approximate mean is 172,3. 172,3. Right. Now, boys and girls, if you don't know how to get your calculator into the two columns, you've got to go into mode and stat and investigate a little bit from there onwards. Obviously, it varies from model to model, but what I find is there's always one person in the class that knows exactly how to get everywhere. Much, much easier than manually sitting and multiplying. Also, because the table is in front of you, you can easily see if perhaps you made a mistake at some point. Right, let's have a look at the next question. I've done that. The next question asks us to draw a histogram. Now, I'm quickly going to talk to you guys about what we do for a histogram, and then in our break, you guys are going to draw the histogram, and afterwards, we will compare notes. Remember, the bars have to touch each other. We need headings on all the axes, and we also need an overall heading. So guys, quick break. Let's draw our histograms, and we'll compare notes afterwards. Welcome back, guys. Hopefully you've finished your histograms and you are ready to compare notes. Right, guys, firstly, you need a heading, and I'm going to call my histogram heights of soccer players. Then frequency on the y-axis and my classes on the x-axis. Very important that we have a scale, so I'm going to say 1, 2, 3, 4, 5, and you only have to label up to your highest one, which in this case is 7. Very important also, the width of your classes need to all be the same. So you can't have one that's fatter or skinnier than the other. Look, mine are all 2 blocks. For a histogram, your individual bars need to touch each other, and then of course you also need to label the classes. I haven't done it all the way through, so I'm hoping that you guys will be able to do this, but you would have done this since grade 9, so I can't imagine that it's too much of a problem. Right. The next question asks us to compare the mode for the ungrouped and the grouped data, and to tell us which is a better measure of central tendency. Now, I've had a squiz through the data here. I've underlined 168 because it appears 4 times. So it would look to me as if the mode for my data is, if it's ungrouped, is 168. Right, so 168 is my mode for my ungrouped data. However, if I look back at my diagram, my histogram, my modal classes, and this data set is bimodal. My modal classes is 170 to 175 and 175 to 180, right? Just to explain quickly, bimodal means that there's 2 modal classes. Now, it would appear to me that there's quite a big difference between the modal classes and the actual mode. So I would say that the mode for the ungrouped data would be the best measure of central tendency. Remember, guys, ungrouped data is always more accurate. It's just not always very practical to work with big pieces of ungrouped data. All right, let's have a look at question 4. Question 4 is a lovely question. The data is grouped and it is given to us in the form of a histogram. So let's read what they have to say. The histogram below shows the number of passengers that travel in Alfred's minibus taxi per week over a period of 48 weeks. So let's have a look at the histogram. So we've got our class intervals with our number of passengers, 400 to 500, 500 to 600, and on the y-axis we have the number of weeks. The first question that we are asked is to calculate the modal interval. Now, calculating the modal interval, especially if the data is given to you in a bar graph or in a histogram, is really very easy. We'll just be looking for that bar that's the highest. So let's have a look. It seems very, very obvious that the modal interval is this one, which I'm going to color in pink, and that is from 700 to 800. Very quick, easy visual question. Let's have a look at the next one. Still on Alfred's minibus taxi and the same histogram, we now want to know the total number of passengers to travel in Alfred's taxi. Now guys, because the data is grouped, this is going to be an estimate, but it should be fairly accurate. Now what I'm going to do is I'm going to calculate the midpoint of each of these intervals. So from 400 to 500, my midpoint will be 450. And from 500 to 600, 550, 6 to 7, 650. I'm sure you guys get the idea. 750, 850, and 950. So the class midpoint is calculated by taking the lower boundary, upper boundary, adding them together and dividing by 2. And let's indicate the midpoints with a dot over there. Now I'm going to have a look at the frequency side, at the number of weeks. So I'm going to say 400 to 500, and I've now given it the midpoint 450, happens 4 times, for 4 weeks, right? 500 to 600, 6 weeks. 650, or 600 to 700, 12. 750, 16 times. I'm just reading off my graph. 8 times. And finally, twice. Now, the first question doesn't ask me for the mean. It asks me for the total number of passengers. But I know when I calculate the estimate mean, I'm going to take the total number of passengers and I'm going to divide it by the 48 weeks. So that's really already just a little step in getting to my estimate mean. So how am I going to do this? I'm going to say 450 times 4 plus 550 times 6 plus 650 times 12 plus 750 times 16 plus 850 times 8 plus 950 times 2. So you're going to add all of those together. And you can do it straight onto your calculator. But let's do that. 450 times 4 plus, put a bracket there, makes it easier, 550 times 6 plus 650 times 12. Ooh, I'm making my bracket different now. Let's fix that. 650 times 12. Maybe not a bad idea, guys, just to write this out in case you make a small little mistake somewhere. At least your teacher can see that you are onto the right idea. I think that's very important. As teachers want to give you guys marks, you've just got to show us some working so that we can do that. Now I've already put this into my calculator, and the total number of passengers that I got was 33600. So 33,600. How did I calculate that again? I got the midpoint of each interval and I multiplied it by the frequency and added them all together. Right, let's have a look at our next question. The next question asks us to calculate the estimate of the mean. Now guys, the word estimate will always be used when we're working with group data, because remember, we don't have 100% accuracy if we work with group data, but it's much easier. So let's have a look. Now, usually when we calculate the mean is the sum of all the values divided by the sample size. So now, I've already done the sum because I did that when I did the total in the previous question. And remember, my answer was 33,600. And now I divide by 48 because the data was taken over a period of 48 weeks. And my answer is 700. Now, if you guys look back at your graph, it's very important to see whether this looks realistic. Guys, there's a lot happening over here in the 7 to 800, so that looks to me like it could be a realistic estimate mean. Right, let's look at the next question. Still talking about Alfred's taxi. And the question asks me to estimate the median. Now remember, boys and girls, the median is the middlemost number if my data is arranged from smallest to biggest. Now, I don't have the individual sets of data anymore. I've got the group data. So I need to figure out in which one of these intervals will my mean lie. Now, 48 weeks were looked at, right? So I'm looking for between the 24th, 25th, that value. That's where I'm looking for, right? So let's have a look. From 400 to 500, I've dealt with 4 weeks in total. From 5 to 600, I've dealt with 6 weeks in total. From 6 to 700, I've dealt with 12 weeks in total, bringing me exactly halfway. So my median interval will be 700 to 800, right? So all you need to do is get halfway to the frequency and count. 10 weeks altogether, 22 weeks altogether, and between my 24th and my 25th value will then fall in the class 700 to 800. Guys, these measures of central tendency often corroborate each other. So in other words, often my modal class, my estimate mean, and my median will be pretty close to each other. Now let's have a look at our final question. Not too much to do with stats, just a little bit to see if you guys can calculate. If it is estimated that every passenger traveled an average distance of 5 kilometers, how much money would Alfred have made if he charged £3.50 per kilometer? Now guys, it should have rather been how much money has he taken in, because of course not all of that money is profit. He has to pay for petrol, but we know what they mean, so let's do that quickly. I'm going to take the total number of passengers, which was 600. And I'm going to say, well, each of them traveled 5 kilometers, and for each kilometer traveled, £3.50 was charged. And the answer to that sum will give us what we need. So let's have a look. 600 times 5 times £3.50, and that's a lot of money. 588,000 Rand. Okay, so quite a lot of money there. But remember, obviously, this is 48 weeks. It's a long time. It's almost a year. And he had to pay the drivers, and he had to pay for petrol, and we all know how expensive petrol has gotten these days. Right, guys, that was question 4. Information given to us grouped on a histogram. Very nice. And we just had to interpret that information. Right. Let's have a look at what is next. Now, we have spoken so far about measures of central tendency. Our measures of central tendency look at a point that my data converges to. And my measures of central tendency are mean, median, and mode. Now we're going to move on to measures of dispersion. Now, measures of dispersion is an indication of how spread out or dispersed my data is. So let's talk quickly about our different measures of dispersion. Most of these you guys probably have met in grade 9 already. Right, so the first one is my range. The range of my data is quite simply my highest data value minus my lowest. So if a whole lot of kids wrote a test in class and the top mark was 90 and the bottom mark was 30, then the range of the marks would be 90 minus 30, which is 60. Right, then let's quickly talk about percentiles. Now, percentiles divide our data equally into groups of 100. So it says the Pth percentile is the value V that divides the data into 2 parts, such that P% is less than V and 100 minus P% is greater than V. All they're saying is, if I look at the 30th percentile, 30% is less than 30% of my data values will be less than that value, and 70% will be more than that value. Together they have to add up to 100. the word percentile should have given you that clue. Let's have a look at the following ordered set of data. I've got 10,3, 11,1, 13, 13,9, 14,2, and 19,8. So the value of the first data piece is obviously 10,3. Its rank is number 1 because it's the first data piece. Its percentile is 0. 11,1 is the ranked second. Its percentile is 20. Now, if I have a look at the third data piece, which is then also ranked third, 13,0, I can say that 13 is the 40th percentile because there are 2 out of 5 values that are less than 13. Remember, 2 out of 5 is the simplest fraction of 40 out of 100. And there are 3 out of 5, which is basically 60 over 100 simplified. That is greater than 13. Right. Now, more on measures of dispersion. We've now spoken about range. Fine. So range, percentiles. We've spoken about percentiles. We also need to talk about quartiles. Now, quartiles are measures of dispersion around the median. Quartiles are the 3 data values that divide an ordered data set, arranged from smallest to largest, into 4 groups, where each group contains equal numbers of values. So basically, Q1, Q2, and Q3 will take my data set and divide it into 25%, 25%, 25%, and 25%. So, the value of Q2 is if I take my data set and I arrange it from smallest to biggest and I get the value slap bang in the middle. If it's an odd number, if it's an even number, it will be between 2 values. Now, Q2, halfway between my data set, also corresponds to the 50th percentile. Now, that would make sense. Then Q1 divides the lower half of the data, the lower 50%, into 2 bits. So Q1 corresponds to the 25th percentile, and then Q3 to the 70th percentile. So this is 1/4 and 25 over 100 for the percentiles is the same. 1/2 and 50 over 100 and 3/4 and 75 over 100 comes to the same thing. Right. There's also something that we need to talk about called the interquartile range. The interquartile range is if I take the Q3 and I subtract the Q1 from it. So it's like range, we're subtracting, but instead of subtracting the highest and the lowest, I will now subtract Q3 and Q1, but we'll get to that a little bit more later. Right, so let's have a look at a question that deals with these measures of dispersion. Mrs. Long is a high jump coach at Roseland High School. She records the heights jumped by the boys in the high jump team. Lorata is one of the members of the team. The following are the heights in meters of his last 12 jumps. So we are given the heights in meters and we are asked to do all sorts of things. Now, the first thing that I am going to do with these jumps is I am going to put them in order. The moment we're talking about range and interquartile range and percentiles, it just makes a lot more sense to put the data from smallest to biggest. And in fact, I like to give it to my students from smallest to biggest because it can take so much time just arranging them. So my first high jump is 1,68. Let's put a little line through. The next one is 1,70. The next is 1,74, 1,78, then 1 meter 80, sure, 1 meter 81, 1 meter 85, this is really very high, 1,9 meters, then I'm going to start in the next line, 1,90, 1,95, 1,98, 2 meters, and 2,01. Right, always a good idea, guys, once you've arranged them, just to quickly count and see if you've got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait, let me just start again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And the question clearly says 12 jumps. So I obviously must have written something twice. And I'm quickly going to go back and see what that was. 1 meter 70. Let's check if I've got that. Yes. 1 meter 68. Tick it off. I know it sounds like a mission, but everybody makes mistakes. 1 meter 78. I've got it. 1 meter 90. Pretty sure I saw that one. 174. There we go. 185. There we are. I know this takes a while, guys, but you know, you don't want to be working with an inaccurate data set and then have to forego a whole lot of marks. 195. Got it. 198. Got it. Then 2, 2,02 and 1,8. One comma 8, 2 meters, and 2,02. So guys, what I've done here is I've written 190 twice, so that's all fine. I've sorted it out, thank goodness. Right, let's look at the questions. Determine the median height jumped by Lorato during his last 12 jumps. Now we need to count and we need to say, all right, 1, 2, 3, 4, 5, 6. And from here, 1, 2, 3, 4, 5, 6. So my median will lie in between these two. So let me mark it over there. Always check 1, 2, 3, 4, 5, 6 on the one side, 1, 2, 3, 4, 5, 6 on the other side. That's perfect. So my median is going to be 1,81 plus 1,85 divided by 2. And that will be 1,83. Okay, so if we've got an even data set, our median will be in between two values. Right, let's look at the next question. Oh, I think the questions are all on the same page. The range of Lorato's heights. Okay, so the range will be the highest, which was 2,02, minus the lowest, which is 1,68. Let's use a calculator. 2.02 minus 1.68. The range is then 0,34 meters, or if you want, 34 centimeters. Let's just keep it in the same unit. Okay, now next we are asked for the interquartile range of this data. Now before we can find the interquartile range, we have to obviously find Q1 and we have to find Q3. So let's do that. Okay, here's my organized data. Now I need to divide my data in half again. So that was Q2. So now for the lower, for Q1, I'm going to divide the lower half into halves. So there's 3 on each side and 3 on the other side. And it's 1,74 plus 1,78. So Q1 will be 1,76. I've simply added the 2 together and divided by 2. I now need to do the same at the upper half of my data, 3 data pieces on each side. 1,95 plus 1,98, so there's a difference of 3, so that's going to be 1,96,5. Wait, let's just do it on the calculator. 1.95, sorry, plus 1.98 equals divided by 2. That's 1,965, as I said, right? So this Q3 is 1,965. Now remember the question asked us for the interquartile range. So the interquartile range is Q3 minus Q1. Q3 is 1,965. Q1 was 1,76, right? Minus 1,76. Out with the calculator, minus 1.76. We just fix that, 1.965 minus 1.76. And my IQR, or my interquartile range, is 0,205 meters. Let's write that down. 0,205 meters. It's actually very important, guys, that you put the units. Let's see if we've done all the questions. No. The last question says, the athlete in the high jump team were told that if their 75th percentile was 1,95 or higher, they would qualify to take part in an inter-high competition. Does Lerato qualify to compete at inter-high? Now remember, guys, 75 percentile is the same as Q3. 50th percentile is the same as Q2. 25th percentile is the same as Q1. So let's have a look. What was Q3? 1,965. So her 75th percentile is 1,965, which is higher than the 1,95 required. So yes, Lerato does qualify to take part in inter-high. Right, guys, we're going to take a short break, but we'll be back straight after the break to finish off the rest of statistics. So don't run away, just stretch those legs and come right back to your TV set. Right, I hope you guys feel refreshed and that you're ready for the last installment of this lesson. Let's go straight on to question 6. The mathematics marks of 200 grade 10 learners at a school can be summarized as follows. So there were 4 unfortunate people that had between 0 and 20, then 10, 37, and so we go. Right, so the data is given to us, nicely summarized. And the first question is for us to calculate the approximate mean mark for the examination. Now, I'm going to do my calculation on here. I have to find the class midpoint, okay? But now, what bothers me a little bit with this one is that the first class is 0 to 20, where the rest of the classes are different sizes, and that's a bit of a problem. So 20 to 30, 30 to 40, 40 to 50, and then again a bigger class here at the end, but I'm just going to deal with it. So let's find the class midpoint from 0 to 20 is 10. And I'm going to say 10 times 4, put that in my calculator. Then the next class midpoint between 20 and 30 is, of course, 25, 35, you see a pattern, 45, 55, 65, 75, and my last class midpoint is 90, so we must just be very careful there. Right. I just want to find on my calculator quickly to see how it is set up at the moment. Wonderful. If you have a Casio calculator, you can set it up so that you have a X table and a frequency table. That makes it so much easier to calculate the estimate mean. I've shown you guys how to do it without the calculator and before with the calculator, so we'll just get a variety of methods going. Right, so I'm going to move my calculator over here. And in my X column, I'm going to enter my class midpoint. So let's do that. So my first class midpoint is 10. Press equals in between. 25 equals 35 equals 45 equals 55 equals 65 equals 75 equals and 90 equals. As I said before, guys, usually the class sizes are the same, but they're not now. But we're just going to apply what we know what to do. Okay, so let's go right back to the top. Oops, I keep on getting to the top and then... Right, so I'm at the top. Now, in the frequency column, I'm going to enter the frequencies. So I'm going to say 4 equals 10 equals 37 equals, and remember to put the right ones together. You can't just randomly enter anything. 36 equals 26 equals 24 equals 20 equals. Right. Now, to calculate the estimate mean, I'm going to press AC, Shift 1. I'm going to go to number 4, and I'm going to select 2 because that is X bar the mean. And the mean mark for these learners is 53.95%. Obviously, guys, you'll have to check the rounding instructions. You might be told to round to the nearest whole number, in which case it will be 54 and so forth. But let's just write down 53.95 for now. $53.95. And that was percent, so that's great. Right, let's look at the next question. Okay. Identify the interval in which each of the following data item lies. And the first one that they talk about is the median. Okay, guys, now the median will be between the 100th and the 101st value, right? So it'll be in between those values. Now we're just going to count over here. I'm going to say, well, up to here, I've looked at 4 learners. Up to here, I've looked at 10 learners. So 4 and 10, and then 37. And then 43. Now, up to here, the ones indicated in pink, the total of the number of learners is already 94. Now, I know then that my median will lie in the next class, 50 to 60, because there's 36 kids in there. So by the time I'm finished with 50 to 60, I'm already on 130 learners. So the median will lie in 50 to 60. Brilliant. Moving along. Now we have to identify in which of these groups the lower quartile lies, and I've got a sneaking suspicion the upper quartile is the next one. Yes. Okay, so the lower quartile and the upper quartile. So let's just do this and say, well, I know that Q2 lies over here. Okay. So now for the lower quartile, I'm looking for the 25th value between the 25th and the 26th. So up to here, I've dealt with 14 values. By the time I get here, sorry, boys and girls, correction, the lower quartile, 25% of the data, but there are 200 students, so I'm looking for the 50th. Where does the 50th from the bottom lie? So up to here, there's 14, and then I add 37. So by the end of this group, which is 30 to 40, I've already looked at 51 learners, so that means that Q1 will definitely lie in there. Right. So now, when I'm looking for Q3, I'm looking for the 150th learner, 75%. Remember, there's 200 altogether. So I've already said, okay, so let's add from the beginning 4 and 10 and 37 and 43 and 36 brings me to 130. Now, if I add 26 for the next one, I am at 156. So it means that the 150th learner ranked wise will lie there. Right, so it is quite possible to determine the class size or to determine in which class the Q1, Q2, Q3, and so on lie. Now I've got to determine, next up, there's another question, identify the interval in which each of the following data items lie, and now I'm on to the 30th percentile, okay? So the 30th percentile will be the data piece that is ranked 60th, right? Because 60 people will be below that data piece, and 60 people out of 200, of course, is 30%. So let's just have a look here. I think we've already said that up to here, I'm at 51. So the 60th data, up to the end of this next class, I'm already at 94. So the 30th percentile, which is the 60th value, will lie in the class 40 to 50. Right, we now know about percentiles, interquartile range, quartiles. I'm now going to talk to you guys about something called the 5-number summary and a box and whisker diagram. Now, a box and whisker diagram, or a box and whisker plot, is one way in which I can graphically display my measures of dispersion. Now, in order for me to draw a box and whisker plot, I need to know the 5-number summary. Now, the 5-number summary consists of the minimum value in my data set, the maximum value of my data set, Q2, Q1, and Q3. So if I have the values of the minimum, Q1, Q2, Q3, and the maximum, those 5 numbers, then I am able to draw something called a box and whisker plot. Now, we will have a look at a box and whisker plot in a second. Let's have a look at the first question though. 82 learners in grade 10 wrote a test, again a test, at the end of the second term. The teacher analyzed the scores and summarized in the 5-number summary. So the minimum value was 8%. The maximum value was 97. The median, also known as Q2, was 68, Q1, 48, and Q3, the upper quartile, 76%. Right, let's look at the questions. The first question asks me to calculate the range of the data. So that's pretty easy. I'm just going to say 97 minus 8. So the range is 97 minus 8, and that is equal to 89. Right, easy enough, 89%. The next question asks me for the interquartile range. So for the IQR, I'm going to say 76 minus 48. So 76 minus 48. And that gives me 28%. Right. And then the next question asks me to comment on how well this group of learners performed in the test. Now, if I have a look at the difference between the upper quartile, 76, and the median, I see that here there's only an 8% difference. But if I have a look at the difference between the median and the lower quartile, this is my semi-interquartile range, there's a difference of 20%. Now, the best way to comment on how the students did is really to draw a box and whisker diagram. They don't ask us to do one here, but I'm going to show you how to do a box and whisker diagram by using this example so that you guys know what you're in for when we do the next one. So let's do that quickly. Basically, all a box and whisker diagram is, boys and girls, is a graphical representation of my interquartiles, my 5-number summary. The first thing that I'm going to need is just a scale. Okay? It is important that you divide your data up equally. You won't always be able to do it perfectly, but I'm going to go 0, 10, 20. See, I keep to equal intervals, more or less. 30, 40, 50, 60, 70, 80, 90, and 100. Right. I kept them as equal as I could. They don't look 100%, but that's fine. Now what you're going to do is you're going to, and you must use a ruler for this, I'm going to draw a line on my minimum value. Now my minimum value is about 8%, so I'm going to put it there, just before the 10. Then I'm going to draw a line on my lower quartile, which is 48%, so that is there. Just a second, my line's not on the same level, so let's do it there. Okay. That's more or less 48%. Then my median, which is 68%. Another line over there. And my upper quartile, 76. Almost forgot about that. That's about there. And my highest value, 90. Then, the three middle ones, I am going to make a box out of. And these from the box to my maximum, and from my box to my minimum, I'm drawing my whiskers. Now let's have a look at what this means graphically. It means that 25% of the kids had between 8 and 48. 25% had between 48 and 68, 25% between 68 and 78, and another 25% from 76 to 100. Now, to me, it is a lot easier to draw a conclusion about how these students did by looking at this. Guys, 75% of the students passed the test. So I would imagine that they did quite well. Okay, so my comment on this data set would be they did well. 25% of the kids had almost distinctions, 25% had over 68, and 25% had over 48. So generally speaking, this class did really, really well. Right, so let's get another little bit of practice in the art of drawing a box and whisker diagram, and let's look at our final question. It says, draw a box and whisker diagram, or a box plot, they can also call it, for the following set of data. Right, now let's have a look. Oh goodness, this is wonderful. Our data, can you guys see, has been arranged for us from smallest to biggest. 1,25, 1,5. Yes, it has already been prearranged, which is really nice. Okay, so when we draw a box and whisker plot, we've got to think in terms of our 5-number summary. So that is the first thing that I'm going to do. I'm going to write down the minimum value. Then I'm going to write down the maximum value, and of course, if they're in order, that's not really a challenge. 1,25 is my minimum, and 5,1 is my maximum. Now I'm going to determine Q2. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data pieces. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And between these two guys, remember, the median divides your data into 2 equal parts. So this is Q2. Okay, so the Q2, obviously I have to add the 2 together. Let's do that quickly. 3,2 plus 4,1. Sorry, 3.2 plus 4,1 divided by 2. And this is going to give me a syntax error, 7.3. 0.3 divided by 2. Goodness, 7.3. That's why I always say it's easier just to work in your head. So my value for Q2 is going to be 3,65. So let's write that in. 3,65. And I'll put it over here as well. Q2 is 3,65. Right, now I need to find Q1 and I need to find Q3 so that I can divide my data again. So Q1 falls between 2,5 and 2,5. Obviously 2,5 plus 2,5 divided by 2 is 2,5. So that's easy enough. And then Q3 falls in between 4,75 and 4,8. Right, divided by 2. And that's 4,775. So let's write that in as well. 4,775. Now, it's really important, guys, to choose a scale that makes sense, because they just asked us to draw a box and whisker diagram. Now, my range of my data isn't that big. My highest value is 1. And sorry, my lowest value is 1,25 and my highest is 5,1. So I'm going to have to at least choose a scale that can represent the halves and so on properly. Ideally speaking, you would want to have graphing paper, because if you have graphing paper, of course, you can make sure that you do this properly. Okay, so I'm first just going to divide the data from 1 to 5. You don't have to start at 0. So 1, 2, ooh, I'm trying my best, 3, 4, and 5. Okay. So my first line will be on 1,25. So there's half between one. That's, I guess, actually, boys and girls, at this point, before you confuse yourself, make sure that you label. Right. Now I'm going to get my line out again. My first line will be on 1,25. There's a halfway between 1 and 2. So let's say that's about there. Next line will be for Q1, which is 2,5. There we go. Then 3,65. So that's a little bit over half here. Just keep it realistic. Q3, 4,7 over here. And let's say 5,1 is over there. Okay, you don't need these arrows. That just happens to be the line that I picked. Then we change the middle lot into a box. And there are our whiskers. It's very important to remember, boys and girls, that each of these pieces represents 25% of the data. Now, people tend to think that there are more data pieces in the bits that are longer. Like, for instance, here, that looks really short. So people tend to think, oh, there's less data there. That's not true. The data is equally divided into 25% pieces. The reason why this line over here is longer, that line is longer, and that line is shorter, is because between the minimum value and that value, there's a bigger range. But in that range, there are an equal number of data pieces. Very, very important to remember. Right, guys, so we've covered a lot in today's lesson. Measures of central tendency, mean, median, mode. We looked at our measures of dispersion. We've looked at histograms. We looked at estimate means. We've looked at modal classes, estimate medians or median classes. Statistics is not difficult. The key to doing well, though, is to make sure that you know exactly what everything is and that you practice, practice, practice. We hope that you guys have enjoyed today's lesson on statistics and indeed that you will join us again next time. Goodbye.